morning. Today we will continue with the exercise 19D. In the previous video we did till question number 3. Today we are going to begin with question number 4. Question number 4. Look at the board. Question number 4. The question is to find foot of the perpendicular. Foot of the perpendicular. This is the main question. Now, to find the foot of the perpendicular, the information we have is the vertices of a triangle are so and so and so. Here, in this question, we are given the vertices of the triangle, the coordinate of the vertices of the triangle. Now, the first question is, write down the equation of BC, and then second part, the perpendicular from A to BC, right? So you have to write two equations. You have to write the equation for the BC, and also you have to write the equation for the perpendicular from A to BC. And after calculating these two equations, then the question is, hence, find the coordinate of the foot of the perpendicular. So, this question, in order to understand this question, first of all, let us have the diagram. Let us have the diagram. So, with the diagram, the question will be more clear. So, here we have a perpendicular. We have a triangle. We have a triangle. Is it okay? This is A, B, and C. We are given the coordinate of the three vertices. The coordinate of A is 0, 5. The coordinate of B is -1, -2. And the coordinate of C is 11 and 7. Is this okay? So, the first part of the question here is to find the equation for BC. So, we will calculate the equation for BC, right? Then we have to find out the equation for the perpendicular from A to BC. So, let us draw a perpendicular from A to BC. Is this okay? This is the perpendicular. Let us name this as a D. So, the second part is, first equation you have to find out for BC. Now, second equation you have to find out for AD, right? Please remember that AD is perpendicular to BC. Is it alright? Now, writing equation of BC is very simple because we have the coordinate of the 2 point. So, using the 2-point formula, we will be able to write the equation for BC. Next one is AD. Because AD is perpendicular, AD is the altitude drawn on BC. So, for writing the equation for AD, we can use the coordinate of A and we can use the slope of AD. And that slope of AD we can get after writing the equation of BC. Because BC is perpendicular to AD or AD is perpendicular to BC, therefore the product of their slope will be equal to -1, or the slope of one equation will be the negative reciprocal of the slope of the another one. So after writing this equation, we will get the slope of this line, and then we can write the negative reciprocal of that slope of BC, and we can have the slope of AD. And that's how, by using the slope of AD and then this coordinate, we can write down the equation of AD. Clear? First of all, I'm explaining you the strategy. How are we going to solve this question? Now, after writing this equation, the last part of this question is to find the coordinate of the foot of the perpendicular. Foot of the perpendicular is D. So, the last part of the question is to also find out the coordinate of point D. This is the foot of your perpendicular AD. Hope I am very clear. And for finding the coordinate of this point, it's very easy, because what we can do is we will find the point of intersection of AD and BC. So by finding the point of intersection of AD and BC, we will get the coordinate for D, because this is the point of intersection of AD and BC. So whole working rule is very clear. With this, now we are going to begin the question. So, solution. First of all, we are going to write the equation for BC. Equation of BC. Right? Equation of BC formula we will use is y minus y1, 2-point formula. Y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into y minus y1. This is the 2-point formula. Is this very clear? Now, this point we can consider as x1, y1 and this point we will be taking as x2, y2. Right? Let us put it now. Y minus y1, y1 is negative 2, is equal to y2 minus y1, that is 7 minus minus 2. 7 minus minus 2 divided by x2 minus x1. So 11 minus minus 1. 11 minus minus 1 into y minus y1. Y minus y1. Sorry, x minus x1. X minus x1. X minus x1. And x1 is minus 1. Is it alright? Now let us solve this. In the next step, here itself I will continue because the question is lengthy. So y plus 2 is equal to 7 plus 2, 9. Then 11 plus 1, 12. And then x plus 1. Right? This we can simplify. 3 3 is a 9 and 3 4 is a 12. Right? After this we can do cross multiplication. So with 4 we will multiply y plus 2. So this is 4y plus 8 is equal to, now with 3 we will multiply x plus 1. So 3x plus 3. Is this very clear? So now we will write this equation because we will need the slope of this one. We can write this equation in any way we like, but because we need the slope of this BC so that we can also find out the slope for AD. Therefore, I will write this equation in the slope and y-intercept form. So this will be 4y is equal to 3x plus 3 minus 8, and then 4 will go right side. This implies your y is equal to 3 over 4 x minus 5. So this is your equation, and then this is 4 also here. Is this very clear? So this we will name as equation number 1, and this is the answer of your first part. Now we want to write the equation for this AD. So therefore we will take out the slope of this line. So the slope of this line will be, if I will name this as M1, it will come as equal to 3 over 4. Right? Now since AD is perpendicular, since AD is perpendicular to BC, this implies the slope of AD, which is I'm denoting as M2, will be the negative reciprocal of this, negative reciprocal of 3 over 4. So it will come as equal to minus 4 over 3. So this becomes the slope of your AD. Now we can write down the equation of AD. So equation of AD, right? We will use the one slope and 1 point, and slope formula. Clear? And that formula is y minus y1 is equal to slope into x minus x1. Clear? So put the values. This we are for this line AD we are taking consider this as x1 y1. So y minus 5 is equal to slope is negative 4 over 3, and then x minus 0 because x1 is 0. Hope I am very clear. Now when we simplify this right hand side, this is coming as equal to minus 4 over 3x. Done? Now we can simplify and write this in the proper form. So with cross multiplication, this 3 will be multiplying this one. So I am taking this 3 as positive. So 3y minus 15 is equal to minus 4x. And finally, rearrangement we will do. And 4x also will be taken to right side. Oh, sorry, left side. So 4x and this plus 3y. And this 15 we can send to that side. If you keep it on the same side also, there is no problem. This is your equation number 2. So now we are done with 2 parts of this question. We have calculated the equation for BC and also we calculated the equation for BD. Is it okay? This is your equation of AD and this was the equation of your BC. So 2 parts is done. Am I understood? Now the third part we will do is we will now find the coordinate of point of intersection. Is it okay? So for this we will solve this equation because this is the equation of your BC, and then we will solve this equation This is the equation for AD. So by solving these two equations, we will be able to get the coordinate of the point of intersection of BC and AD, or you can say you will get the foot of the perpendicular AD. Is it okay? So now we will continue. I will delete this part and then we will solve these two equations and find the coordinate of D. So finally we got these two equations. We are going to solve these two equations and then find the coordinate of the foot of the perpendicular. So we are going to solve it. So we are going to, because you can see in equation number 1 we have made a formula for y. So therefore we will use the method of substitution. So we'll say substituting value of y from equation 1 in equation 2. So let us put the value of y in this equation number 2. So 4x plus 3, and for y we will write this. So 3 over 4x minus 5 over 4 is equal to 15. So here itself I will continue. This is 4x. Now with this you multiply. This will be 9 over 4x, and then this into this will be minus 15 over 4, and right hand side is 15. Now we will correct the like term. We will simplify these two together and this will be together. So simplifying this together, the LCM will be 4. So 16x and plus 9x. Now this goes to the right hand side. So it becomes 15 over 4. This will become positive plus 15. Right hand side when you simplify, the LCM is coming 4. So 15 plus 60. Right? Now this 4 and this 4 I will simply cancel. This is coming 75. This is 16 plus 9, 25x. 25x is equal to 75. And therefore, your x will be equal to 75 divided by 25 is equal to 3. And this is the value of your x coordinate. So the x coordinate of this point is 3. Now we are going to calculate the y coordinate. So for finding the value of y, we can put the value of x in equation number 1. So putting value of x in equation 1. So what happens? Y is equal to 3 over 4 into x, and x is 3 minus 5 over 4. So this is coming 3 3 is a 9 over 4 minus 5 over 4. Now LCM of these two will be same 4 only. Numerator will be 9 minus 5 is equal to 4 over 4 is equal to 1. So this is your y coordinate. So finally we got the coordinate of the foot of the perpendicular. Is this very clear? Thank you. Now we are moving on to question number 5. Question number 5. Find the equation of the straight line passes through the point of intersection of the two lines, so and so, and parallel to the straight line y minus x is equal to 8. The question is that we have two lines. We have two lines, right? Now the question is to find a line which passes through the point of intersection of the two lines. The two equations that is given. Find the equation of line, or write the equation of a line which passes through the point of intersection of the two line. Clear? And it is also parallel to a third line. Is this okay? So in this condition, what we can do is, since we know that the line passes through the point of intersection of the two lines, so therefore we can solve the two equations and we can find the coordinate of the point of intersection, right? And because the line passes through that point of intersection, so this point can be used for writing the equation of that line, which is parallel to a third line. Now the line that the equation which you are going to calculate is because parallel to the third line, therefore the slope of your line and the slope of the third line has to be same. Is it okay? So let us see then. First of all, we'll find the coordinate, right? Because the two lines are intersecting. This is solution for question number 4. So the two equations we have is x plus 2y plus 3 is equal to 0. This is the first equation. Another equation we have is 3x plus 4y plus 7 is equal to 0. So these are the two equations we have. These are two equations we have. These are the equations of the two lines which are intersecting, and the line passes through the point of intersection of these two lines. Therefore, we are going to solve these two equations so that we can get their point of intersection, coordinate of the point of intersection. So for solving this, we can use the elimination method. I'm choosing this coordinate y to eliminate, right? You can choose any one of these two. I'm going to choose y, and therefore the LCM of these two y will be 4, and therefore the first equation will need to be multiplied by 2, so that the coefficient of y also becomes 4. Clear? So equation number 1 will reduce to this will become 2x, 2y into 2, 4y, and 3 into 2, 6 is equal to 0. This is our equation number 3. Now we are considering equation number 2 and then this equation, and then eliminating y. For eliminating y, you need to change the sign. That means you are going to do subtraction. So down all the signs will change. So this is cancelled, and this becomes equal to 3x minus 2x is simply x, and this is what 7 minus 6 is equal to plus 1 is equal to 0, and therefore your x coordinate is equal to minus 1. So the value of x is minus 1. Now we can find the value of y by putting it in equation number 1 or in equation number 2. So I'm going to put the value of x in equation number 1. Putting value of x in equation 1. So for x we can write minus 1 plus 2y and plus 3 is equal to 0. Simplify. This minus 1 plus 3 will become plus 2. So this is 2y plus 2 is equal to 0. In the next step, 2y is equal to minus 2. This 2 goes to right side. And finally, your y is equal to minus 2 divided by 2 is equal to minus 1. So the coordinate of y also is equal to minus 1. Is this okay? So the coordinate of the point of intersection is minus 1, minus 1. Coordinate of point of intersection is how much? Negative 1 and negative 1. X and y both we got negative 1, negative 1. Clear? Now the line whose equation you are going to write is passing through this point. So this point will become the coordinate of your required line. Second thing is your line is a parallel to the third line, and that third line is y minus slope of the given line, and your line is y minus x is equal to 8. Y minus x is equal to 8, and therefore from here we can write down the equation for in the slope and y-intercept form, x plus 8. Now we wrote the equation in the slope and y-intercept form, so the coefficient of x will become the slope of this line. Therefore your m1 is equal to 1. Coefficient of x is just 1. Clear? And now your line which you are going to calculate is parallel to this given line. Is parallel to this line. That means this slope and the slope of your required line will be same. So with this slope and then this coordinate, we can write down the equation of our required line. So we will say therefore required equation will be using slope and 1 point, right? So y minus y1 is equal to slope into x minus x1. Now put the value in this. Y minus y1, that is minus 1, is equal to slope is 1, and x minus x1, that is again minus 1. So this side it becomes y plus 1, and this side will become x plus 1. This plus 1 cancel. So your equation is y is equal to x, or you can, this is your equation. You can either live in this form, or if you want you can write this also in this form. X minus y is equal to 0. So this finally becomes your equation of that line, which passes through the point of intersection of these two lines and is parallel to this given line. Is it alright? Thank you. Now the next question is question number 6. This is the last question for the day and last question of this exercise. This question number 6 is a very similar to question number 5. So let us see what is question number 6. Find the equation of the line through the intersection of so and so and perpendicular to the line 2y minus 3x minus 5 is equal to 0. So if you compare question number 6 with question number 5, both are exactly same with a minor difference. The minor difference is, in the previous question, the line that you calculated was a parallel to the third line, and this time this line is going to be perpendicular. So only there's a difference in the slope. Is it okay? So what we can do is, once again we will process this question also in the same way. Solution of question number 6. Question number 6 solution. Right? So first of all, let us find out the point of intersection of the two lines. So the two lines are, the first line we have is y plus x is equal to 9. This is your first equation. Let us name this as first equation. Another equation is 2x minus 3y, right, plus 7. Is it? And is equal to 0. So this is your equation. Now in this equation we need to do some arrangement so that simplification is easy. Here you can see the order of writing this alphabetical letters are x first and y next. This is written in order, but in this first equation we don't have this in the order, so we can change it. We can change, so we will rearrange this. This is x plus y. Whether it is x plus y or it is y plus x, it does not make any difference, but our purpose is getting solved. Clear? So anyway, first of all let me show you that it was y plus x, right? And then I will first of all arrange this equation, then we will write the name. So this we will write as, this implies your first equation is x plus y is equal to 9, and now I will name this as equation number 1. Now in equation number 2, in the first equation, because we have constant on the right hand side, so here also we will try to take this constant on the right hand side. So the second equation is 2x minus 3y is equal to minus 7, and now this is equation number 2. After this, now we will start operating it. In this question, once again I am going to consider y to eliminate, because one y is negative, another y is positive. So it will be easy, we can do it by addition. And the LCM of these two coefficients will be 3 only. That means once again here equation number 1 is going to be multiplied by 3. So the first equation will reduce to 3x plus 3y is equal to 27, right? And now we can just do addition and eliminate this y. This becomes 5x and this becomes 20, and this implies your x will be equal to 20 divided by 5 is equal to 4. So you got the coordinate of x, you got the x value 4. We can now find the value of y by putting it in equation number 1, because equation number 1 is more easy. So putting the value of x in equation 1. So for x we will write 4 plus y is equal to 9, and this implies your y is equal to 9 minus 4 is equal to 5. Now we got the coordinate of the point of intersection. Clear? So coordinate of point of intersection is 4 and 5. Now the line that you are going to write, now the equation of line that you are going to write will pass through this point. So this point will also belong to the required line which you are going to calculate. Now second thing is that now your line is going to be perpendicular to the third line, right? Now slope of the line, we will calculate slope of the third line. Slope of line 2y minus 3x minus 5 is equal to 0. This is your equation. Now we will write the slope of this line. For writing the slope of this line, 2y is equal to 3x and plus 5. This 3x and minus 5 both will go to the other side, so this both negative will become positive. And finally, your slope of this line we can calculate by writing this in the slope and y-intercept form. So 3 over 2x plus 5 over 2. And therefore, the slope of this line is m1 is equal to 3 over 2. Now, the line that you are going to write down, the equation of the line that you are going to calculate, or you are going to write the slope of that line, because it is perpendicular to this one, therefore the slope of your line will be the negative reciprocal of this one, and therefore we can calculate this implies m2 will be the negative reciprocal of 3 over 2, so your required slope will be negative 2 over 3. So with this point and this slope, we can write down the equation of our required line. So the equation of required line is equation of required line is what? Using the same formula, y minus y1. So y minus y1 is 5 is equal to slope, that is negative 2 over 3 into x minus x1, that is 4. Now we can simplify, cross multiply. This implies 3 into y, 3y minus 15 is equal to, with minus 2 you can multiply this x, minus 2x and then plus 8, right? Now we can write down we can rearrange it and get the final equation. So your final equation will be, this implies 2x will be taken to this side, will become positive, so 2x, then this will be 3y as it is equal to minus 15 we will send to that side and will be added to 8, so it becomes 23, and this becomes your equation. This is your required equation which passes through the point of intersection of these two lines and is perpendicular to this third line. Is it okay? So with this we have completed the exercise 19D. Hope you might have understood each and every question. I did all the questions of this exercise. So you just need to understand the concept and then do the question by yourself. Thank you so much for watching the video. Enjoy learning maths. Take care and stay safe.